The universe is vast and ancient, an endless expanse of stars, planets, and mysteries. For centuries it has seemed silent, indifferent to our questions and our search for company in the cosmos. But on July 6, 2025, that silence was shattered in a way no one could have predicted. A transmission from the James Webb Space Telescope arrived. Data so unusual, it immediately set the scientific world abuzz. Its source? Proxima Centauri B, the rocky exoplanet orbiting our closest stellar neighbor, just over 4 light-years away. Scientists at NASA and ESA are in a frenzy, rechecking models, poring over every byte of data, and debating what this could mean. The initial findings? Something in Proxima B's atmosphere defies all expectations, anomalies that simply shouldn't be there, according to everything we know. This isn't science fiction, it's the culmination of decades of searching, of building ever more powerful telescopes and dreaming of a day like this. The JWST was aimed at Proxima B to look for signs of an atmosphere, maybe even water vapor, clues that might hint at habitability. Instead, it found a chemical cocktail that doesn't fit any known model, gases and compounds that don't belong together, at least not on a lifeless world. The world is holding its breath, as news of the discovery spreads like wildfire across the globe. The news didn't come from a carefully planned press conference, but through leaks, frantic online chatter, and a storm of speculation. The data points to an atmospheric composition that's simply wrong. It's not what we expect from a barren rock, nor from a planet teeming with simple life. It doesn't match the signature of a dead world, nor does it resemble the chemical fingerprints of a thriving biosphere. It's something else, something that challenges our understanding of planets, atmospheres, and perhaps even life itself. The implications are staggering, and the questions are only beginning. For millennia, we've gazed at the stars and asked, are we alone? For so long, the universe answered only with silence. Now the JWST's data hints at an answer, one that is as mysterious as it is profound. There are no alien cities, no obvious signs of civilization, just a chemical fingerprint that doesn't belong, and that no one can yet explain. Every scientist who sees the data is left with the same burning question. What is happening on Proxima B? Is it a new kind of chemistry, or something more? The journey to answer that question starts now, as humanity turns its eyes and instruments toward our nearest neighbor with renewed determination. Humanity stands on a precipice, poised between the known and the unknown, ready to take the next step into the cosmic dark. The universe may finally be whispering back, and this time, we're listening closer than ever before. Proxima Centauri B, our next-door neighbor, just 4.2 light-years away. In galactic terms, that's practically our backyard. Proxima B orbits a red dwarf, Proxima Centauri, much dimmer than our sun. To stay warm, it hugs its star, completing a year in just 11 Earth days. This places it in the habitable zone, where liquid water could exist. But life here would face fierce challenges: flares, radiation, and a likely tidally locked orbit. One side bakes in perpetual daylight, the other freezes in endless night. Only a thick atmosphere could create a habitable twilight ring between extremes. That's where scientists think life might survive, a world of eternal sunset. For years we wondered, is Proxima B a barren rock or something more? That's why it became a top target for the JWS. Now, we may finally have an answer. The universe's greatest secret could be right next door. Enter the James Webb Space Telescope, our most powerful cosmic eye, and a marvel of modern engineering. This telescope is not just a tool, it's a gateway to the unknown, designed to answer some of humanity's biggest questions about the universe. Launched in 2021 after decades of planning and international collaboration, JWST sees the universe in infrared, not just visible light. This unique ability allows it to look deeper into space and further back in time than any telescope before it. By capturing infrared light, it can peer through thick clouds of cosmic dust that block ordinary telescopes, revealing hidden stars, galaxies, and even the atmospheres of distant exoplanets in remarkable detail. Its massive gold-plated mirror, spanning over 21 feet, collects the faintest glimmers of light from worlds light-years away. The key to its power is a technique called transit spectroscopy. When a planet like Proxima B passes in front of its star, some of the starlight filters through the planet's atmosphere, carrying with it clues about the air's composition. Different gases absorb specific wavelengths of light, leaving behind unique fingerprints in the spectrum. These patterns are like barcodes, telling us exactly what's present. By analyzing these spectral fingerprints, JWST can reveal what Proxima B's air is made of: water vapor, carbon dioxide, methane, and potentially even signs of life-supporting chemistry. Before Webb, astronomers could only guess at the makeup of exoplanet atmospheres, relying on indirect evidence and limited data from older telescopes like Hubble. Now, for the first time, we can analyze them directly, unlocking secrets that were once out of reach. Stationed a million miles from Earth, far from our planet's heat and light, JWST enjoys a clear, cold view of the cosmos, undisturbed by earthly interference. It watched Proxima B with patience, waiting for the perfect moment to catch its secrets as the planet crossed its star. This is why Webb is a true game-changer for astronomy and planetary science. For the first time in history, we can truly study the air of another world, searching for the building blocks of life beyond Earth. And what it found was astonishing. Evidence that could change our understanding of the universe forever. So, what did Webb find? The results stunned everyone. First, Proxima B has a substantial atmosphere, already a huge surprise. The composition, even stranger. Carbon dioxide and nitrogen, expected. Hints of water vapor, exciting, but then methane, in quantities hard to explain without life. On Earth, methane mostly comes from living things. Even stranger, Webb detected dimethyl sulfide. On Earth, produced almost exclusively by marine life. Could geology explain it? Maybe, but nothing fits perfectly. The real kicker, the carbon isotope ratio. Life on Earth prefers carbon-12 over carbon-13. Proxima B's air shows the same skew. Any one of these findings could be a fluke. But all three together? That's a pattern. A pattern that, on Earth, screams life. Scientists are triple-checking, but the evidence is compelling. Proxima B's atmosphere is a riddle, one that may point to biology. The scientific world erupted. In labs and observatories across the globe, researchers dropped what they were doing to pore over the data. Newsrooms scrambled to cover the story, and for a moment, the world seemed united by a single, electrifying question. Could we finally have found evidence of life beyond Earth? Dr. Evelyn Hayes, astrobiologist. We've spent decades listening for messages, scanning the skies for radio signals or alien artifacts. Turns out, we should have been sniffing. The discovery of these molecules in Proxima B's atmosphere was a revelation, a new way to eavesdrop on the cosmos. The chemistry is undeniable, though not yet proof. Social media exploded with speculation, memes, and heated debates. #Proxima B and #Webb finds trended worldwide as people from every continent joined the conversation. Dr. Ben Carter, JPL, the methane-DMS combo is a level 3 biosignature. Hard to fake geologically, it's the kind of signal we've dreamed of finding. So far, nothing fits as well as life. Excitement clashed with caution. Some called it a new Copernican moment, others urged restraint. Skeptics, like Dr. Lena Petrova, warned, "We're interpreting data from a world we've never seen, using instruments at the edge of their limits." Proxima Centauri is a star known for its tricks, violent flares, unpredictable outbursts, and a history of confounding astronomers. We must exhaust all natural explanations first. The scientific method demands skepticism, and every possibility had to be considered. The debate raged in labs, online, and across continents. Scientists collaborated and argued, united by curiosity and divided by interpretation. Teams tried to model exotic volcanism, strange mineral reactions, and every conceivable non-biological process that could explain the data. Every non-biological explanation was tested, scrutinized, and so far found wanting. But for now, the simplest answer, the one that fits all three clues, is life. It's a hypothesis that grows stronger as alternatives fall away. Science demands rigor, but wonder is hard to contain. The possibility of life on another world stirs something deep within us all. The process is adversarial, designed to weed out error, to challenge every assumption and test every claim. Yet the evidence keeps pointing in one direction. Each new analysis, each peer-reviewed paper seems to strengthen the case. The world is watching, waiting for confirmation. In classrooms, coffee shops, and living rooms, people are asking, what if we're not alone? If true, this is the most profound discovery in human history. It would change our understanding of life, the universe, and our place within it. The search for life has never felt so real, so immediate, or so close to an answer. The stakes have never been higher. The next steps will demand patience, precision, and global cooperation. The universe may not be silent after all. And as we listen, we may be on the verge of hearing the answer to one of humanity's oldest questions. What could cause these strange signals? The leading theory, microbial life like Earth's algae or bacteria, altering the planet's chemistry. Maybe a vast ocean or damp soil in the twilight zone teems with simple organisms. Another possibility, unknown geology. Proxima B's unique conditions could create chemical oddities we've never imagined. Cryovolcanism, exotic mineral reactions, these must be considered. And then, the wildest idea, a techno-signature. Could the signals be the byproduct of alien technology, not biology? It's speculative, but not impossible. For now, scientists favor the simplest answer, life. But the data is so strange, even the wildest ideas stay on the table. Humanity stands at a crossroads. The JWST's data is the first credible challenge to our cosmic solitude. It's not proof, but it's a clue, a beautiful, maddening clue. The great silence is broken by a whisper, and everything has changed. More observations are planned. JWST and other telescopes will focus on Proxima B. Scientists will look for seasonal changes, more biosignatures, and even try to image the planet directly. The race to understand has begun. If life is confirmed, it means life is common, a cosmic rule, not an exception. Our place in the universe would be forever changed. We'd no longer be a lonely miracle, but part of a grand cosmic story. The quest to understand Proxima B will define a new era of exploration. Are we alone? Maybe not. And if not, what else awaits us in the dark?